calculator, your best bet is to graph each transformation at each time that you do one, and keep track of it, because you're going to have to keep track of your domain, your range, and you don't have a calculator to check it. Now, obviously, you can check yours from your homework, but on the test, you won't have a calculator for it. So you're going to have the same thing as the review. You're going to have a non-calculator part and then a calculator part. The y-intercept, again, if it's feasible, if it applies. It didn't apply here because you would need your calculator to do that. So leave that be. The x-intercept you can absolutely find. You can leave that in fraction form. And make sure you keep track of your domain and your range. Easiest way, make sure you start with your domain. Start with your original domain and keep track of where it's going. And keep track of your range. Keep track of your intercept and the x-intercept here. That's a good place to start. The only thing that's going to set this off, well, for your domain part, other than the reflection maybe, but if it's across the other way, is your horizontal transformation. Make sure also you use these words. If you don't use these words, you're not going to get credit. Don't tell me move to the left. Give me horizontal shift. So keep track and you move to the left 3. Take 3 away from here, 3 away from here, 3 away from here, and keep track of your new points. And then from there, do your next transformation. Obviously, when you move it, you're going to change your x-intercept, but at least you get a feel for which direction you're going in. Because you're not going to have a calculator until you solve that one algebraically. Okay?
Yep.
Questions at all? No. I'm only really giving you basic transformations. Basic that we've done on all of these. These flip to an exponential equation, set it equal to x, flip it to an exponential equation, use your rules. Here's your scientific notation, base 10. Log is exponent in base 10, so find out what's the 10 to the what power. ln, that's a property that cancels out. This one comes down. I'll probably give you 1 or 2 of those. They're nice to do. Questions?
For 3, please put the answer -2.
Yes.
Okay.
Is that good?
Yeah.
Okay. Can you see it? I could make it bigger.
Small, yeah.
Yeah. Oops, too big.
I can see that one. It's always giving you issues.
It always does. Always does. Better? Okay. All right. The next part too, you don't really need your calculator for these parts anyway. You're just condensing or expanding. Use your product rule, your quotient rule, your power rule, and get rid of your square roots first. So give me exponents for those.
Do you have to put the numerator in parentheses?
Not on that one, because order of operations is going to do your add and then subtract.
Okay.
So if you did, that's absolutely fine. Just to keep things safe, it does not hurt anything to put it there. And that's absolutely fine. Do I need to write base 10? No. So if you don't put a base 10 in there, it's understood to be a base 10. Ellen, this is as far as you're going to go with this guy. It doesn't have a perfect square. We don't want to separate this. That's not where your product goes. Good?
If it was a minus and it wasn't a square, would we have to write it out?
No, you could leave it like that, because there's nothing else, like you're not going to be able to reduce it down to anything different. All right, these guys. Now you could leave your absolute value. If you square your absolute value and you even get a negative out of it, it's always going to become a positive. If you left me the absolute value sign, I'm fine with that. It's weird looking, yeah, but that one we need to, because we need to keep this one positive. underneath the radical has to stay positive. When we square your absolute value, if it's negative, well, it's not going to come out negative anyway. So that's always going to be positive. But this guy, we have to be sure that this comes out with your positive. We don't want to take that one away. This one will work either way because it will come out positive, and when we square it, it will come out positive. And the last one, don't forget to bring up that exponent first. You okay with these? Just going back and forth with expanding and condensing? And they work for any base log. Whatever base log we put this in, they work for that. Your bases will all be the same in every expression. I won't give you a base 10 and a base 2 in the same expression. You can't do that. So they'll all be the same bases as well.
For number 10, are those the same answer?
Yeah, either way you want to put this. You do need the absolute value under your radical because that has to be positive. But what I was saying before is, out of an absolute value, you'll always come out positive. When we square it, you'll always come out positive. So that one you don't have to have. You can go either way with that. The absolute value with the square looks a little bit strange, but it's still going to work the same. Okay, now here's your calculator answers. Again, you see the one with the 2x in it. Okay, remember, set up a small one. Work out your small one, but think out loud to yourself how you do it. And then set this one up the same way. Make sure you check your ln after you do this, that you have a valid one that's going to work. If you know, you can't take a log with a negative because your domain is from 0 to infinity. This guy too, make sure you check. If we had to reject, this is both solutions. If we have to reject this, and there's no other solutions, then it's no solution. It's there, I don't know where. Oh, it's not.
And the 2 for number 12 work?
Yeah. Well, then you can check them. They're not rejected because of any negatives. They would be rejected right here. If it said ln of -4, you'd have to automatically reject it. You can't take the ln of a negative number. But if you want to make sure they work, then plug them back in. Rejecting them is before we even see if it works, because we know it can't happen. We know when we bring this up here, 0, this is going to give me the -1. So it might be a good idea to work your domain first. My domain is here. Work your domain first. If this is outside of your domain, reject it. Questions? No? Good? Here's an interest compounded continuously. We only have the compounding with interest, not with regular things. So here's your PERT, which is the annual interest rate. You're looking for a rate. Even that rate is not too small, but remember the rates are small. We want to solve these algebraically on your test tomorrow because we're doing the log part of it. Can you graph it and see that your answer is correct? Absolutely. But I need your algebraic solution. Yes?
When you give an answer in percent, do you round with the decimal or do you round the percent?
I would round here with the decimal. You could even give me 3 places. You don't even have to put it into a percent. You can leave it this way. I rounded a little bit more because we're moving it. But if you go to 3 decimal places, that's fine. Good. So that wasn't so bad. And then here's a population. Populations are popular here. I like the population ones because it forces us to do this part. Forces us to do this right here, the 1 minus r. If we're increasing, we're 1 plus r. It still works off of this.
Wouldn't it only be 39? Or, wait.
It should be 11.
Yeah.
Yeah, it should be 11. I took this one out of the book. It should be 11. It hasn't yet reached that 12. We talked about that yesterday in class. If you round to 12, I'm not concerned. But as long as your rounding rules were okay. But technically, we didn't reach that yet. Okay. When will the population be 30,000? God bless you. I just have to move this down a little bit. Again, solving algebraically. I did it the long way. You could do it the shortcut way. I did it the proper way, kind of. Take the ln of both sides. Use your product rule. Subtract it. Divide it. Be careful. You need parentheses. If you're not using your fraction key, could you divide by 55,000 and leave it as a fraction? I'm fine with that. As long as you don't give me a decimal that's reduced or rounded. Don't round until the very end. You get the exact same answer. And label it. When will this reach this? In this many years. Good? No? And again, if you wanted to divide by 55,000, up here, you can just leave it reduced. You do it this way. You can figure this guy out right here. You don't even have to leave that hanging around. Take the ln of both sides or the log of both sides. Leave this as a fraction. And you can solve it that way. It will work out the same. You can use logs or ln. I'm not concerned about that either, as long as you use an ln with base 8. And the last guy, I think this is your last one coming up, right?
Yep.
You're another increasing. Assume that we double. There's our rate double. Every 8 months, this is a cycle. If it said every month, we're x. If it says every 8 months, we're x over 8. I gave you years, so you had to convert your years to months.
So, wouldn't it be 60 over 8?
60 over 8. It does probably work with 60 over 8.
Because isn't that what
It
it has
can't
to be?
possibly be for the 60th power. Yes, 60 over 8.
So, wouldn't that show me?
Didn't you get the same answer?
I got,
Yeah, I just forgot to write the over 8. But if I did 2 to the 60th power, that'd be a humongous number. Try it again. And when will it reach 25,000? Okay, so we're looking for an increase here. When is it going to reach 25,000? And give your answer. You could just leave your answer in months. If you want to give your answer in years, divide it by 12. Whichever way you do that, just make sure you put the label for it, either months or years. I asked this one in years, so if you wanted to go this one with years, that's fine. Leave it in months. I'm fine with that. So are we good? Questions at all?